We are going to do a quick review of slope and the three ways that you have previously learned how to find slope. In general, the slope is the steepness of a line. How steep a line is its slope. When we get technical about it, slope is a ratio. Slope is defined to be the ratio of a line's vertical change to its horizontal change. So, how much does a line move up and down in relation to how much it moves left and right? A line is made up of points, and points have x coordinates and y coordinates. So if we look at points moving up or down, we're looking at how the y coordinates are changing. And if we look how points are moving left or right, we're looking at how the x coordinates are changing. So the vertical change of a line is the change in its y coordinates, and the horizontal change of a line is the change in its x coordinates. So the slope of a line can be seen as the change in y over the change in x. Mathematicians like to use symbols for things when they can. So they use the Greek letter delta, it looks like a triangle, to represent change. You will see this Greek letter used in math, and you will also see it used in science because it means change. So delta y over delta x means the change in y over the change in x. So this is sort of the shorthand way to write all of this. A line's vertical change over its horizontal change is the slope. Now you have learned that slope can be four different things. So we're going to quickly review this here. If a line is going up from left to right, we always read a line like we read a book. We read left to right. It has positive slope. If it's going down from left to right, it has negative slope. A horizontal line has zero slope, and a vertical line has undefined slope. One of the ways that you have learned how to find slope is from a graph. So here I have a line graphed on a coordinate plane, and we have to find 2 points in order to find the slope. And in order to find the points, you want to choose points that go through corners of the graph. So like that point right there goes through this little T. We want to choose points that go through the corners of the squares of the grid. So I'm going to choose this point right here. And then I see another point that goes through corners right there. So you choose 2 points on the graph. You draw a right triangle using the grid lines connecting those 2 points. Now, I drew the triangle going above the graph. You could also do this triangle down here because together this makes a rectangle, so it really doesn't matter. Okay, so once you do that, you're going to count. The change in y is up or down. How many spaces up or down does my triangle go? Well, the change in y is 1, that's 1 space. And then you're going to count the change in x, that's left and right. That is 1, 2 spaces. So the change in x is 2. So the slope of this line is 1 over 2, or 1/2. Now, it's important to remember it doesn't matter which 2 points you choose. You can choose any 2 points and get the same thing. So, for example, let's say I had seen this point and this point, and I chose this triangle. Well, my change in y is 2 spaces. My change in x is 1, 2, 3, 4 spaces. So my change in y over my change in x would be 2/4, which is 1/2. So regardless of which 2 points you choose, they will simplify to be the same value. Okay, now that line had positive slope. This next line, notice it is going down from left to right, so I know it's going to have negative slope. I'm going to go ahead and write my negative to begin with so I don't miss anything. So I'm going to pick 2 points. I see a point right here. Remember, the points need to go through the corners of the squares of the grid, and I see one right below it. I'm going to draw my triangle connecting them. My change in y, that's my up or down movement right here, it is 1. And my change in x, how many spaces is it across? Right there, it is also 1. So -1 over 1, the slope of this line is -1. Again, it doesn't matter which 2 points you choose. I could have chosen this point and this point. I draw my triangle, My change in y would be 3. My change in x would be 3. Negative 3 over 3 is still negative 1. Does not matter which 2 points you choose, they will simplify to the same value. Next, we're going to choose, or I'm sorry, we're going to find slope from a table. So I have here, these are points that are on a line: 0, 4, negative 1, 6, negative 2, 8, negative 3, 10. I could graph these points and find the slope of the line, but graphing is not always efficient. So I'm going to use what I know about slope. I know that slope is the change in y over the change in x. So I'm going to look at my y values. How do I get from 4 to 6? I add 2. From 6 to 8, I add 2. From 8 to 10, I add 2. So my change in y for this line is 2. Now I'm going to look at the change in x. This is on the left-hand side of the table. From 0 to negative 1, I go down 1. Negative 1 to negative 2, I go down 1. Negative 2 to negative 3, I go down 1. So 2 over negative 1, that will simplify to negative 2. It is okay for slope to be a whole number. You never want to change slope to a mixed number. Either leave it as an improper fraction, a simplified fraction, or a whole number, but never change it to a mixed number. So my next one, I want my change in y. My y values in the table are on the right, so I'm going to look at that first. From negative 9 to negative 7, what do? The change from negative 9 to negative 7 is up 2, right? I added 2. Negative 7 to negative 5, I add 2. Negative 5 to negative 3, I add 2. Now, what's the change? I'm looking at the x side of the table. What's the change from 0 to 4? I add 4. From 4 to 8, I add 4. From 8 to 12, I add 4. So my change in y, that's on the right, is 2. My change in x is 4. 2 over 4 simplifies to 1/2. So the slope of this line, if I were to graph it, these are 4 points on a line. If I were to graph it and find the slope, the line has a slope of 1/2. Now we're going to find the slope between 2 points. Again, I could graph these 2 points. I could graph 2, 9, I could graph 0, 4, I could draw the line through them, I could draw a slope triangle, count my change in y, count my change in x, find the slope. But graphing is a little inefficient. So we're going to use a mini table. This is exactly what we did just a second ago, but there's only going to be 2 points in the table. So I'm going to take my point 2, 9. Now remember that the first coordinate is x and the second coordinate is y. So I want to put that point in going across. The x coordinate needs to go in the x column. The y coordinate needs to go in the y column. 0, 4 has an x value and a y value. The x value is 0. The y value is 4. Now I'm going to do exactly what I did a second ago. What is the change from 9 to 4? The change from 9 to 4, I go down 5, right? What is the change from 2 to 0? The change from 2 to 0, I go down 2. So my change in y is negative 5. My change in x is negative 2. What is a negative divided by a negative? It's a positive, so this slope is going to be positive, and I'm going to leave it as 5/2. Do not change it to a mixed number. That is simplified. You're done. All right, so this one I have the point negative 6, 1, so I'm going to put negative 6 in the x column and 1 in the y column. 4, negative 2, I'm going to put 4 in the x column and negative 2 in the y column. What is the change? Let's look at the y values. What is the change from 1 to negative 2? That's down 3, correct? Okay. What is the change from negative 6 to positive 4? We add 10, right? To get from negative 6 to positive 4, we add 10. So my change in y is negative 3. My change in x is 10. A negative divided by a positive is negative, so the slope of this line is negative 3/10.